Good morning students. Now we are going to see some more problems how to find the Z transforms. For the signals, just consider this example. For the signal x of n is equal to 7 into 1 by 3 power n into u of n minus 6 into 1 by 2 power n into u of n, and find the Z transform and also ROC. First write down the given signal. Given signal is x of n is equal to 7 into 1 by 3 power n u of n minus 6 into 1 by 2 power n u of n. You know the from the definition you know what is x of z. X of z is equal to summation n is equal to minus infinity to plus infinity x of n into z power minus n. So substitute the x of n in the expression. So summation n is equal to minus infinity to plus infinity. I am substituting the given x of n in the formula. 7 into 1 by 3 whole power n u of n minus 6 into 1 by 2 whole power n u of n of z power minus n. Here we have the two signals. So I am going to divide this summation into a two summation. Anyway, 7 is in this the first expression. The first one 7 is a constant. I am taking out from the summation. So now the expression becomes 7 summation n is equal to minus infinity to plus infinity 1 by 3 power n u of n into z power minus n. In the second one, the 6 is a constant. We can take it out from the summation. So minus 6 summation n is equal to minus infinity to plus infinity 1 by 2 whole power n u of n into z power minus n. Now I am going to change the limits based on u of n. What is u of n? Already last class we discussed. We know u of n. What is u of n? U of n is a unit step function. It exists only n is greater than or is equal to 0. Correct? So now I am going to replace the limits to n is equal to 0 to infinity. 1 by 3 power n, u of n is anyway 1 into z power minus n minus 6 into, in the same here in the second expression also u of n only. So u of n, it exists only n is greater than or is equal to 0. So the limits change to n is equal to 0 to infinity 1 by 2 power n z power minus n. Now I am going to combine because both are power n only. I am going to, because we have the formula only anything power positive n. So 1 by 3, this z becomes z power minus n. We can write it as a 1 by z power n. So 1 by 3 z, if you multiply means 1 by 3 z power n minus 6 into, in the second also 1 by 2 z power n. So now this is in the form of, already we know what is the formula for summation n is equal to 0 to infinity a power n. Yeah, correct. 1 by 1 minus 1 by a. Okay. Here what is a? 1 by 3z. Same thing in the second expression, if you apply means 1 by 1 minus, instead of a, here 1 by 2z. In the first expression it exists only 1 by a is less than means 1 by 3z is less than 1. Here in the second expression 1 by 2z is less than 1. So if you want you can simplify, otherwise you can keep as such also, nothing will happen. Now we got x of z for the given signal, and also we have to find the reason of convergence. How to find the reason of convergence? From the limits. So we got two limits. What are the two limits? One is 1 by 3z is less than 1, 1 by 2z is less than 3z is less than 1, 1 by 2z is less than 1. Now I am going to write, so 1 by 3 I am keeping this side, left hand side, and taking the z2. So by cross multiplying, 1 by 3 is less than mod z, and the second one is 1 by 2 is less than z. So this one, this is nothing but a, whenever if you are getting the both are less than, so if you write in the z, mod of z is greater than 1 by 3, mod of z is greater than 1 by 2. So if you are getting both are greater than, means we have to write maximum of 1 by 2 and 1 by 3 will gives the reason of convergence. So what is the reason of convergence here? So both should exist, both should maximum value. So mod of z is greater than 2. In this case, if any problem, if you are getting like this, both if you have the z values are 2, both are greater than, means always we have to take the maximum of both. So for example, maximum of 2 comma 3 is nothing but the 3, the reason of convergence is 3. In this case, max of the maximum value of 1 by 2 comma 1 by 3 is 1 by 2. Okay, understood? Next we'll solve one more problem. So same thing, before going to solve one more problem, I'm going to draw the reason of convergence for the given. So reason of convergence is nothing but how to draw the reason of convergence. Always we have to draw the reason of convergence only in the z plane. So z plane having real axis and imaginary axis, and normally we have any plane we have x and z, x and y. So here x axis is nothing but a re of z, the real of z, and y-axis is nothing but the imaginary of z. Correct? Indicates poles and zeros. How many poles are there here? Only one pole, that is at origin, and one zero is two poles. One is 1 by 2 and another one is 1 by 3, and 0 is at origin. So always, already I told, reason of convergence, if you are getting the 2 means always the maximum value. So greater than is nothing but, already the last class we discussed, if it is greater than means outside or inside the outside. Good, outside the circle. Okay, clear. This is the reason of convergence for the given signal. We'll see some more problems. Okay, find the transformation of x of n is equal to minus u of minus n minus 1 plus 1 by 2 whole power n u of n. Find the ROC and also indicate. See, in this problem they are asking us to indicate poles zeros location of x of z in the z plane. Okay, always, what is the first step? Write the given expression. What is the given equation? X of n is equal to minus u of minus n minus 1 plus 1 by 2 whole power n into u of n. From the definition, what is x of z? X of z is equal to summation n is equal to minus infinity to plus infinity x of n into z power minus n. What is the next step? Substitute the given signal in the equation. Now x of z becomes, x of z is equal to summation n is equal to minus infinity to plus infinity minus u n minus n minus 1 plus 1 by 2 whole power n into u of n of z power minus. Here we have the two equations now. Same thing what we did in the previous class. So divide this one into your two summations. One will be summation n is equal to minus infinity to infinity minus u minus n minus 1 into z power minus n, and second one is 1 by 2 whole power n into u of n into z power minus n. Already the last problem we discussed, minus we can take it out from the equation, from the summation, and u of minus n minus 1, how to find the value, where it will exist. So from first u of n is 1 for, here u of n is 1 for only the n is greater than or is equal to 0. Next, how will get u of n minus 1? By shifting u of n one shift right side. So u of n minus 1 is 1 for n is greater than or equal to 1. So 0 becomes 1. Next, u of minus n minus 1 is 1 for, so that is nothing but it is the positive from 1 to infinity. It is from minus 1 to minus infinity. The positive side will become the right side by using the reflecting property. So u of minus n minus 1 is 1 for n is less than or is equal to minus 1. Okay, I'm saying here in the second expression anyway u of n. So u of n is 1. Only it is 1 from 0 to infinity. The first limit changes to minus infinity to minus 1, and second limit changes to 0 to infinity. And already you know, so we have only positive limits. Correct? I want to change the limits to minus to positive. What we have to change? In the z power n also, the positive, the sign should be changed. So summation, I'm changing everything in 1 because we already practiced. We have to go fast. Minus summation n is equal to 1 to infinity. So here I am changing negative to positive, means here also in the z power also I have z sign also I have to change to z power sign. That is nothing but n sign. Here n limits we are changing, means here n sign also we have to change it. Z power instead of minus n plus n, plus here summation, anyway this is u of n only na, 0 to infinity 1 by 2z whole power n. Okay, clear. Now we can apply the formula. What is the formula? That one, a by a minus 1. Here z is nothing but z by 1 minus z plus 1 by, this is 0 to infinity. If it is 1 to infinity, see we have 1 to infinity means a by 1 minus a. If it is 0 to infinity means 1 by 1 minus a. That is the difference. Okay, now z by 1 minus z plus 2z by, if you simplify this one, 2z by 2z minus 1, we can take the LCM and we can simplify it. Just I took the LCM and I cross multiplied and I simplified it. Here we got x of z is equal minus 4z square plus 3z divided by 1 minus z into 2z minus 1. But one most important is we have to write the reason of convergence. So the first one exists, z is less than 1, and second one is mod of 1 by 2 z is less than 1. So 1 by 2, so I want to write, so 1 by 2 I'm keeping this side, and 2 we can take it by cross multiplication. So 1 by 2 is less than z. So mod of z, if you write, means mod of z is greater than 1 by 2. Mod of z is, one more thing, is less than 1. So if you combine these two, what will come? What will come here? What 1 by 2? 1 by 2 is, 1 by 2 is less than 1 by z, less than 1. It is in between. See, in the first verb, it came in between, correct? It should be, mod of z should be greater than 1 by 2, and it should be less than 1. Correct. Now I am going to indicate. So because in this problem they asked us to indicate the poles and zeros. So we have to simplify, and we have to find the poles. So I still more I simplified. So I took the common minus 2z, will get 2z minus 3 by 2, and in the denominator 1 by z into z, because we have to write the roots of z. So if I take in the second expression 2 common, z minus 1 by 2, 2 will get cancelled. The final expression we got x of z, everything should be z. X of z is equal to z into 2z minus 3 by 2 divided by z minus 1 by 2. Clearly here I indicated the denominator roots. The denominator roots poles. How many poles are there here? 2 poles. Oh, what are the 2 poles? One is z is equal to 1, one is z is equal to 1 by 2. And denominator, denominator roots gives the zeros. How many zeros are there? 2 zeros. One is at origin, z is equal to 0. Next one is 2z minus 3 by 2 is equal to 0. It is nothing but z is equal to 3 by 4. So we have the 2 zeros. One is at origin, other one is 3 by 4. So now by using this one, I am going to draw the ROC and I am going to indicate the reason of convergence. See ma, how to draw the reason of convergence? Where we can draw? Only z plane. So draw the z plane. So z plane having two axes. Now what are the two axes? One is real axis and other one is imaginary axis. And once if you indicate real and imaginary axis, what we have to indicate? We have to indicate poles and zeros of the system. How many poles are there? 2 poles. Poles always indicating with a cross mark, and zeros always indicating with a small circle. So the zeros are 2. So one is at the origin here, 1 in the blue mark indicate, and the other one is 3 by 4. Correct na? 3 by 4. Next one is poles. Poles, how many poles are there? 2 poles. One is at 1. That one circle, orange color circle, and other one is at 0.5. 1 by 2 is nothing but number. So these two are the poles. These two are the zeros. And also always we have to draw from the origin to poles only we are going to draw the circle. So two circles, 2 poles are there, 2 circles, one circle at first pole 1 by 2 and second circle at 1, second pole at 1. So now from the limits, what is the z limits? Z exists. The reason of convergence exists only 1 by 2 to 1. So that is nothing but in this case the z transform exists only in this area. That is nothing but at z is equal to 1 by 2 to 1. So it is in between. In between means we have to draw the 6 circle in between two. Clear? The previous one. So how many possibilities we get? First one is only if it is z is greater than 1 means outside, z is less than 1 means inside. If it is in between means it, if z is in between means the constant the reason of converge exists in between. Correct? If both are if mod of z having the two values means we have to take the maximum of the two values, gives the reason of convergence. How many types we got? Only 4 types. First one is z is greater than means outside, z is less than means inside. If z is in between means like this, it is the z will be in between, and the z values are z exists in the two values means ROC always only have to take maximum of the 2. Okay, clear? Understood? Next class we'll see the remaining topic.